One of the problems most students have in chemistry is stoichiometry. But I promise you, at the end of this class, you're going to understand everything that has to do with stoichiometry. What I'm just going to beg you is that make sure you follow every step one after the other as I'll be explaining each steps. And all of the questions we'll be solving because stoichiometry is all about calculations. So I will have to solve a whole lot of questions with you for you to understand it better. So please make sure you stay through this video in order to understand stoichiometry better. So if this is your first time on this channel, if you find this video useful, please make sure you subscribe. This is Primer's Classroom, where we teach all that has to do with some subjects that you might be having difficulties with. You can leave any subject you have issues with in the comment section, and we're going to treat the subject together and we'll solve all of these questions. So if you're writing any exam or you just want to know more about sciences, please subscribe to the channel. So what is stoichiometry? Stoichio means element, metry means measurement. So what we do in stoichiometry is basically measurement, basically calculations. So we are going to be looking at different elements, doing some kind of calculations, looking at how reactants come together to form products. And this topic is not even difficult. All you just have to think about is, imagine you go into kitchen, you want to prepare something, probably 2 cups of rice in the kitchen. You are going to know the definite amount of water you are going to need for that rice, and you are going to also have to know the amount of salt to be added to the rice. That's if you know how to cook though. On a lighter mode, if you go into the kitchen to prepare, you already know the quantity of things to mix together to get you what you want. So it's the same thing in chemistry. If you're going into the laboratory to prepare water, H2O, definitely you must know the amount of hydrogen to combine with a particular amount of oxygen to give you water. So that is what we are going to do here. So the calculation is based on, how do I know the amount of a particular substance that I need to mix with a particular substance to give me another form of substance, which we call compound. So basically that is what stoichiometry is all about. Now, there are two types of stoichiometry. We have composition stoichiometry and reaction stoichiometry. In this class, I'll first deal with this composition stoichiometry before we move on to the deeper part, because we all need to know how to calculate relative molecular masses, percentage composition, empirical and molecular formula. So if you don't know how to calculate relative molecular masses and percentage composition, this video is for you. And if you also know how to calculate it before, let's practice this together. Then after this, because you will learn one or two things as well, then after this I'll be teaching you the shortcuts and every ways you can calculate when you get to reaction stoichiometry. So now let's pick one or two questions. When you are asked to calculate relative molecular masses, they are going to give you different atomic masses of different elements. So all you just have to do is add up those atomic masses and you will get your relative molecular masses. Let's look at what I'm saying with this question. So in this question, you are asked to calculate the relative molecular mass of the following compounds: Na2CO3, Na2SO4.5H2O, CaCO3, lead-2-triazonitrate 5, and you are given their relative atomic masses. So how do we do this calculation? So what you are going to do is that you are going to take the compound, so solution, the relative molecular mass of Na2CO3. That's what we want to calculate. So now, how do you do it? You take, how many sodium do you have in this compound? 2. So that will be 2 into Na. Plus how many carbon? 1 carbon. How many oxygen? 3 oxygen. So when you add all of these values together, you're going to have 2 into 23 plus 12 plus 3 into 16. So this is going to give you 46 plus 12 plus 48. So at the end, all this will give you 106 gram per mole. So now you sum all the atomic masses together and that will give you the relative molecular mass. So that's how to do that part. So let's look at the second one. I want you to be careful with this second question. A whole lot of students used to make mistakes here. They used to use that dot to multiply the values, which is always wrong. So let's see how you're going to do that. So if you ask to calculate the relative molecular mass of sodium tetraisosulfate 6 pentahydrate, that's Na2SO4.5H2O. Just the same way I did the last one, that's how you're going to do this. So when you are doing this, how many sodium do you have here? So that's 2Na plus how many sulfur? I have just a single sulfur. Now this is where people make mistakes. These dots, they used to say, since this is 4 times 5, then they are saying that that will be 20. That's a lie. There are 5 oxygen here and there are 4 oxygen here, so meaning that the total number of oxygen you have in this place is 9. So that will give you 9 oxygen. Then how many hydrogen? 2 times 5, that would be 10 hydrogen altogether. So you're going to now have 2 into 23 plus 32 plus 9 into 16 plus 10 into 1. So if you do that all together, this will be 46 plus 32 plus 9 times 6, that's 144 plus 10. So altogether, this will give you 200. That's 46 plus 10, 56 plus 54, that's 200 plus 10. So that's 232 gram per mole. So the total molecular mass for Na2SO4 dot 5H2O is 232 gram per mole. So you need to know how to do this because we are going to be needing it in moving ahead to reaction stoichiometry. That's why I want us to treat this first. Now, you can calculate that of CaCO3 and lead-2 triazonitrate. Another thing you need to know is how to calculate what we call percentage composition. Percentage composition determines the mass of a substance over the total mass multiplied by 100. That is how you do percentage composition. This is what I'm saying. So if you ask to calculate percentage composition of any element in a given compound, so the percentage composition is going to give you the mass of that substance, mass of a substance over the total mass multiplied by 100. That's how you calculate percentage composition. For example, let's look at these questions. What is the percentage composition of the underlying element in the following compounds? So we have to calculate the percentage composition of carbon. Remember, we calculated Na2CO3 in the last question. So, and the total we got was 106. So to calculate the percentage composition of carbon in this compound, then we're going to have, you remember, carbon was 12. So we got 12 over the total. The total was 106 multiplied by 100. So if you do that, that's 1200. So that's 1200 divided by 106. And that gives us 11.32. So the percentage composition of carbon in that compound is 11.32%. So that's how to calculate percentage composition. So do for the next one, sulfur, carbon, and the nitrogen in lead-2 triazonitrate 5. If you don't know how to write the formula for lead-2 triazonitrate 5, this is how you do it. Lead-2 is carrying Pb2 plus. Trioxo, that means the oxygen there is 3. Nitrate 5 is NO3 minus. Lead-2 is Pb2 plus. So if you change their combining power, that means you're going to have Pb2, NO3, 1. That's their minus 1. That's the 1. So when you change that, you're going to have PbNO3 subscript 2. That's what you're going to have. So when you have this, you can calculate that of nitrogen, or you can calculate. So the number of nitrogen I have here is going to be 2. Number of oxygen is going to be 6 in total. So you can calculate their total relative molecular mass and calculate the percentage composition of nitrogen. So that's how you treat percentage composition. In the next class, I will take series of questions on empirical and molecular formula, and some questions that used to get students confused on empirical and molecular formula. If you have any question that is disturbing you on this aspect, please drop it in the comment section. I'll be bringing series of questions and I'll be solving with you just in a short while. So please try to understand this aspect because we're going to be needing it in the subsequent classes. And that's why I have to treat it first before we move ahead. So please, if you find this video useful, please subscribe to our channel, encourage us to do more. We're going to take our time to explain the whole topic. We have not started. This is not even stoichiometry yet, and this is not the aspect that is to give people problems. We're going to treat that, but we just need this to get into the topic. So you move on to class 2, where we talk about empirical and molecular formula. Then in class 3, we'll be talking about reaction stoichiometry, where the problem really is, and we'll be dealing with that. So please subscribe. I'll see you in the next class.